Let's solve this physics problem about constant velocity motion. If a car is moving to the left with constant velocity, what can we conclude about the forces acting on it? Let's look at our options. Option A, there must be no forces applied to the car. Option B, the net force applied to the car is directed to the left. Option C, the net force applied to the car is zero. Option D, there is exactly one force applied to the car. Let's visualize what's happening. We have a car moving to the left with constant velocity. This means its speed and direction aren't changing. Now, let's look at the actual forces acting on the car. First, there's the weight of the car pulling down. The ground pushes back up with an equal normal force. There's also friction between the tires and the road. And don't forget about air resistance. According to Newton's first law, an object in motion stays in motion with the same speed and direction unless acted upon by an unbalanced force. Since our car is moving with constant velocity, this means all the forces must be balanced. They must add up to zero. So let's evaluate each option. Option A is wrong because there are forces acting on the car. We just saw them. Option B is wrong because if there was a net force to the left, the car would accelerate left. Option C is correct. The net force must be zero for constant velocity motion. And option D is wrong because we clearly saw multiple forces acting on the car. Remember, constant velocity means zero net force, even though there are multiple individual forces acting on the object. The forces are just perfectly balanced